So this is part 2 of your KIN 225 lecture for Wednesday, February 10th. In this part of the lecture, I'm going to introduce the concept of these muscle receptors. One is called the muscle spindle, and the other one is called the Golgi tendon organ. And each of these receptors will send input back to the spinal cord to affect the motor neuron that innervates that muscle. So I've got this diagram where I've got receptors inside the muscle. So this is the muscle, and these are, the green things are receptors. And I've got the brain that's sending input to a motor neuron, and that motor neuron is sending its axon and input to the muscle. So in this diagram, I have the motor neuron and its axon. And then I've got the muscle spindle, which is one of your receptors. And the spindle reacts to a quick stretch on the muscle. So the more you stretch the muscle and the faster you stretch it, the more you'll activate that muscle spindle. And it sends excitatory input back to the spinal cord to cause muscle contraction. So it will activate this motor neuron, and then this motor neuron will send a message to the muscle to cause it to contract. The Golgi tendon organ, on the other hand, reacts to high muscle tensions, and it sends inhibitory input back to the spinal cord, and that prevents muscle contraction. So this is a bit of a summary. Muscle spindles cause this, what's called a stretch reflex. So the muscle spindles are receptors in the muscle that detect stretch of the muscle, and they're responsive to both the speed of the stretch, so the rate of the stretch, and the amount that the muscle stretched. They send an excitatory input to the motor neuron in the spinal cord, and they cause reflex muscle contraction. And then they send inhibitory input to the opposite muscle group to cause relaxation of the antagonistic muscle. So for example, if you activate the stretch receptor in your quadriceps, the quadriceps will contract and cause knee extension. At the same time, the hamstrings receive inhibitory input from that muscle spindle, and the hamstrings will relax to allow the knee extension to occur. The Golgi tendon organ, on the other hand, is a receptor that's found at the junction between tendons and muscle fibers. It's activated by high tension, and it inhibits muscle contraction and would cause the antagonistic muscle to be excited, so it would cause contraction of the antagonistic muscle. In this next section, I'm going to talk about using the Golgi tendon organ and muscle spindle during training and performance. So the first application of these receptors and how you can use them to enhance training and performance is with stretching or training for flexibility. So a Golgi tendon organ, if it's activated, it inhibits muscle contraction and causes the muscle to relax. So this is good to activate if you want to stretch a muscle. So this type of stretching is called proprioceptive neuromuscular facilitation. It's a type of stretching where the Golgi tendon organ is first activated by forcefully contracting the muscle that you want to stretch. That causes inhibition of the muscle contraction, so it causes the muscle to relax, and then it increases the ability to stretch that muscle. So the goal here is to isometrically contract the muscle that you want to stretch and make that contraction very intense. That activates the Golgi tendon organ. It would cause the muscle to relax, and then you'd relax the muscle, and then you can stretch it further. So this is just an example of applying this concept to stretching the calf muscle. So to stretch the calf muscle, you'd want to pull this band this way to get a good stretch of the plantar flexors, so the calf muscle. Before you do this, if you want to use this proprioceptive neuromuscular facilitation, you would push against this band with your toes to do a hard contraction of the calf muscles. That would activate the Golgi tendon organ in the calf muscles. That would send inhibition to the spinal cord and cause the calf muscles to relax. Then you would relax, and then you could stretch the calf muscles a little bit further. So the sequence here is to first contract the calf muscles hard. That activates the Golgi tendon organ, causes the muscle to relax, and then you can relax and get a good stretch of the calf muscles. And this is an example of the same concept applied to the hamstrings. In this case, this person is using a partner to help her stretch. The goal here is to stretch the back of the leg, the back of the upper leg, the hamstrings. And so to use this proprioceptive neuromuscular facilitation, the girl that's leaning against the mirror would push down against the palm of this woman to cause the hamstrings to contract. So she would do an isometric contraction, pushing the leg this way to cause the hamstrings to contract. That would activate the Golgi tendon organ in the hamstrings and send inhibition to the spinal cord to cause relaxation of that hamstrings. And then the partner could then push on the foot to cause the hamstrings to get a good stretch. So the initial contraction of the hamstrings activates that Golgi tendon organ, causes the muscle to relax, and that allows the muscle to be pushed into a more stretched state. And this is just a cartoon to end off this section about stretching.